This is a quick video to go over some of the common errors on data assignment 3, hoping that if it's possible to head off some of the similar errors in data on the fourth data project, that would be good. Some of these are very specific to the kinds of problems that were here, but this is what I would have done in class Wednesday. We would have talked about this a little bit. Probably the most important thing that I think was caused the most confusion is that part 2 and 3 are really not related to each other. We are sticking to the same question from the survey throughout, but in part 2, we're creating a confidence interval and for a proportion, and to do that we have to have a proportion of students who answer a specific way, because it has to be either they said those words or they didn't to get our p hat value. And so it has nothing at all to do with gender. Part 2 has nothing to do with gender. Some people were trying to make part 2 into something about gender as well. I would say make sure before the final exam that you understand how your margin of errors and everything work. This was a correct solution for someone who chose the abortion question and looked at the percentage of people who said strongly agree. This was the most common combination of choices that people made for this question. But this is correct. The p hat value is the number of people who answered that way out of the total 150. The standard error is using the standard error formula, and then the margin of error is 1.96 times the standard error. So make sure you have those three numbers right. There were some people that had some errors in the calculations here. And since there are no more details in the calculations, I really can't tell what you're doing to get the numbers you're getting. So please check those again. But I think that was the only thing that was wrong there. When you move on to the chi-square test, if you're going to use all the responses in the table, like this student did, then your null hypothesis can't possibly be specifying one of those categories. So part 3 will have nothing to do with the word strongly agree. So notice that in this one, the student said the null hypothesis is there's no association between gender and opinion on abortion. The most common mistake here was saying something about an association between gender and the proportion of people who answer strongly agree, pulling that work from part 2 forward. But the way this is set up, since all of the categories for the abortion question are being used here, there's nothing in the chi-squared test that is allowing you to make a specific conclusion about one particular category. So, so when we're using all possible categories from the question, then the null hypothesis can't possibly specify. So this is the correct null and alternative hypothesis. There were a few people that didn't follow the format that I asked you to follow. And so I really did want 2 separate tables here. And the reason is not because I'm just being anal about it, but the reason is that I really want you to write this sentence because I want you in your report to highlight what that second table means. That second table is what you would expect the counts to be if the null hypothesis were true. So if you put them all in one table with the parentheses, you're assuming that your reader already knows that that's what they're looking at. And again, I'm trying to get you to develop your ability to write a report for people who are not necessarily a professor teaching statistics to you this semester. So, so that sentence in between the tables is what I really wanted to see. And so I would recommend in the fourth data project to just look at the sample solution and try to follow the format as closely as possible. I know in the original assignment sheet, I just referred to the sample for formatting. I didn't try to explain the formatting there. So I suspect that people that completely ignored the formatting for the sample probably never opened the sample document. So please open it and use that formatting, because that does give you some more specific instructions about the way the whole thing should be laid out. And then down here, from the chi-square test for the whole table, you can see the p-value is very, very small. And there still are some people who are saying the opposite of what they need to say at the end. So please pay attention to that. This student did this right. The p-value is small. So we do reject, so we have sufficient evidence to support. And then the sentence that's here is just HA. Always, always, always HA. So the only thing that would happen if you had a different p-value is that there, and there, you would say do not. Everything else would be exactly the same. I also was happy that this student took the last part seriously. Some people just ignored it entirely. But the reason I want you to do this discussion at the end is because we really, our conclusion here really is not valid for all SU students, because we did not take a random sample of 150 people from all SU students. We took students that were specifically taking Math 117 this semester as our sample. And so what I want you to do is discuss if there are any ways in which the fact that we only took 117 students would make these results, or could possibly make these results be different than if we had just taken a random sample of 150 students from Shippensburg. And so, so this student couldn't think of any reason why it would, but also discuss some possibilities. So I think that was very good. But the, you know, the one thing that, well, there are two things. In 117, the students generally take this class mostly when they're sophomores. And so that means your ages are very similar to each other, as opposed to a random sample across the university. And then the other thing is that your majors are very specific. There are specific majors that are always in Math 117 and specific majors that are never in Math 117. So that's two different ways in which a Math 117 sample would not be really representative of the whole SU population, that you would differ from a random sample of 150 people. It's not clear what those biases would do to the specific question here, the abortion question, but you could make a case that maybe there's a correlation between your major and how you feel about politics or something like that. Anyway, all I wanted you to do is just discuss it a little bit so I could see that you are reflecting on how this result that you're getting may or may not be all that valid for the whole Shippensburg University population. I think that's it. The only other error I saw multiple times was people using the old data set instead of the new data set. And I think that's just coming from, again, not really fully paying attention to what you have in front of you. You have an email from me, actually you have it twice now, that has 3 files in it, the assignment, the data, and the sample. So please download all of those and look at all of them. And those same 3 files are posted in MyLabs Plus under Data Project 4. So I think if you look at all the information you have and you pay attention to a couple of these issues, then I think Data Project 4 will go great.